Section 2.4 is the integrating factor technique. This is method 4 for solving first order ordinary differential equation. Now, what is integrating factor? To see the meaning behind integrating factor, or what is integrating factor, let us consider the following differential equation: 2x dx plus 2x squared y plus 3y squared plus 2xy dy. Actually, this differential equation is exact. We can check exactness by, if we consider this as m and this one as n, if we find my partial m partial y, which is 2y plus 4xy, and nx, which is partial n partial x, this is 4xy plus 2y. Now, clearly my is equal to nx, so the given differential equation is exact. Okay, so what is integrating factor? You see, if you look at this equation has got a common factor, which is y. If we divide by y, which is okay mathematically as long as y is not equal to 0, we are going to have a new differential equation, which is y plus 2xy dx plus 2x squared plus 3y. So we have divided by the common factor. Doing that, if we check exactness again, we are going to see that we have lost exactness when we divided by the common factor, which is y. If this is m and this is n, just like before, my is equal 1 plus 2x and nx is equal to 4x plus 2. They are not equal. My is not equal to nx. So the new differential equation, it's not exact, which is this, is not exact. So when we lost the factor, we lost exactness. Now, this factor is called integrating factor. The reason we call it integrating factor, because if I multiply it back into the differential equation, I'm going to get this equation, which is exact differential equation, and it can be integrated and solved. So how can I find an integrating factor? If this equation was given to us, which is not exact, how can I find an integrating factor? To find an integrating factor, you have to use the following two rules. We will call the integrating factor mu. You can find an integrating factor if it is function of x only or function of y only. If it's function of x, you can find it using the formula my minus nx divide n dx. And if it is function of y, you can find it using the formula nx minus my divide by m dy. But if the integrating factor is a function of x and y, then it is not possible to find it using ordinary differential equations, so we have to use other methods. Now, how do we use these two rules for finding the integrating factor? The idea is like this. We have to check if my minus nx divide n is a function of x only. If it is, then you find mu x by finding e to the power. Otherwise, we check nx minus my divide m if it is function of y only, and if it is, then we find my by finding e to the power of that. If neither is true, then we have to try other methods. Let us use these two now rules on this differential equation, which we know it is not exact. We also know the integrating factor. So how do we use them? We have to check, like I said, this one. We have to check my minus nx divide n if it is function of x, even though we know that the integrating factor is not function of x, but at least this is how we proceed. My minus nx divide n is 1 plus 2x, this is my, minus nx, so minus 4x minus 2, which is this, divide by n, which is this one, so 2x squared plus 3y plus 2x. Clearly this is not a function of x only, because there is a 3y. So we have to check this now, which is nx minus my divide m, which if it is function of y only. Nx is equal to 4x plus 2 from here, and my is 1 plus 2x, so 1 minus 2x, divided by m, which is y plus 2xy. This is equal 2x plus 1. There's a y which is common factor in the denominator, and we are going to end up with 1 over y, which is a function of y only. So now we can find mu y, which is e to the power of that, so we are going to apply this rule now. Integration of 1 over y dy, this is equal e to the power ln y, and it is y. That's the integrating factor we were looking for, which is this. Now if we multiply it back, we are going to end up with the previous equation, which was exact, and solve using section 2.3. Here I'm just going to repeat now the same steps which we have considered in the previous example. We said what is integrating factor and how to solve using integrating factor. Now these are the procedure, or this is the solution procedure. This is now a differential equation which has to be written in this form. Right hand side is 0, this is dx and dy. Step 1, we have to check partial m partial y and partial m partial x. If they are equal, then it is exact, then this is going to be section 2.3. Otherwise, if it is not exact, if they are not equal, then we have to check my minus nx divide n if it is function of x only. If it is function of x only, then you can find mu x, which is e to the power integration of the same thing. Then go to step 4 and 5. Step 4 and 5 means which are what actually? After finding mu x, which is integrating factor, multiply it into the differential equation to make it exact, make sure it is exact, and then solve it. Otherwise, if this is not function of x only, we have to check nx minus my divide m if it is function of y only. If it is function of y only, then find mu y, which is e to the power of that. And then go to step 4 and 5. These are actually step 4 and 5 now. If after finding integrating factor, either function of x or function of y, multiply it into the differential equation to make it exact, make sure it's exact, and solve it. Let us consider the following exercise. Now, you see here it is dy given and then dx. So let's rearrange it because to avoid confusion. So let's write dx first and then the dy term. Now, this is m xy and this is n xy. My is equal, this is equal to 0 because it has no y. Then this is a product rule, both contains y, so it's 1 ey plus y ey. And nx, which is this, it has no x, so derivative is equal to 0. Clearly, my not equal to nx, differential equation is not exact. And anyway, the question says for integrating factor, so it will not be exact. How do you find integrating factor? We are going to check if my minus nx divide n as function of x only, then mu x is equal e to the power integration of that, which is my minus nx divide n dx. If not, check if nx minus my divide m as function of y only, then mu y is equal e to the power integration of nx minus my, this is m minus my divide m dy. Now, let us see. We are going to start with the first one, which is this. My minus nx divide n is equal. My is this, which is minus ey plus ey, minus nx, which is 0, divided by n, which is this, and that is ey y plus 1. This actually cancels with this, and the answer is minus 1. See, when the answer is minus, either when you are checking that or checking that, when the answer when the answer is a number, is a constant, it can be taken as a function of x only or a function of y only. Okay, but since we are checking function of x, so this will be taken as function of x only, and we can find now mu x, which is, so we are going to say mu x is equal e to the power integration of what we find there, which is minus 1. So this is your integrating factor. We are going to multiply it into the differential equation to make it exact. So let's multiply it here into the differential equation. So it's going to be x minus y, ey minus x dx plus ey minus x y plus 1 dy equal 0. So we multiplied it into this differential equation to make it exact. Let's make sure it is exact, because if we make sure it is exact, we are sure that what we solved until now, it's okay. So this is m. Let's call it m bar, because we have already m here, so we don't want to call another thing as m also. So m bar. Now what is my? My, just like before, it's equal to 1 ey minus x plus y ey minus x, and nx is equal, you see this considered as a constant, which is y plus 1, and derivative of e is e times derivative of the power with respect of x, which is minus. So we are going to put minus here. So this is what? Minus, which is derivative of the power of e. So clearly these are equal if you expand the bracket. So they must be equal. So my is equal to nx. Must be, because we have an integrating factor. We multiply by integrating factor, which means that this differential equation is exact. Exact means this is partial f partial x, which is this, and this is partial f, which is n, partial f partial y. So to find f, we are going to integrate the first one, which is m bar or n bar. We have to see which one is easier. If you are going to integrate with respect of x, you should look at x only, because y is considered to be constant. It's easy to integrate this. This is a constant. You can integrate this easily. If you integrate with respect of y, you are going to integrate y ey, which is by part. So the first one, which is m, it's easy to integrate. So x minus y ey minus x dx. This is equal to x squared divided 2 minus y is constant, so you are integrating e, which is e, divided by the derivative of the power, which is minus 1, so this will become 1, plus constant, which is g of y. This is f. Now we have used partial f partial x, we integrate. Now I'm going to use partial f partial y to find g of y. This way we integrate with respect of x, so we are going to differentiate with respect of y and compare it with n. Partial f partial y here, this is 0, and here you have a product rule, so you have 1 ey minus x plus y ey minus x plus g prime y is equal to n. And what is n? This is n. this is n bar, which is ey minus x times y plus 1, which is ey minus x times y plus 1. If you compare the two sides, this is ey minus x, and this is ey minus x, so g prime y is equal to 0, so g of y is integration of 0, which is equal to constant. So now we can write back our answer, which is f of xy equal to x squared divide 2 plus y ey minus x plus c. And final step, we should write the solution as f of xy equal to constant, so x squared divide 2 plus y ey minus x. No need to write plus c because it will go with the second c on the right hand side.